Thank you so much for having me. I'm really excited to share some results from this project with you. Let me acknowledge my collaborators here: Payal Hati, Mamun Al Bashar, Moin Haider, and Nur Al Alam. And these are kind of like the very. I'm gonna try to get you excited about the study, I hope, and show you some very first results. And there'll be more coming out over the coming months. And the basic problem that I'm working on here is trying to understand how to estimate death rates in settings where there are not good systems for producing death certificates. So usually I'd kind of explain a lot about this problem, but I think most people in this crowd are probably familiar with this. In all the places on this map that are sort of pink or red or clear colored, there's very incomplete systems for collecting death certificates, and in these settings we need strategies for estimating death rates that don't rely on death certificates. I'm going to focus today on adult ages. That's sort of the hardest ages to learn about with respect to death rates. And I'm going to focus on methods that involve some kind of high quality household survey, because in most of the places where we don't have death certificates available, it's still possible to collect high quality survey data. And if you think about it for a second, it's difficult to measure deaths or to estimate death rates from a survey for two big reasons, I think. So one is that we're used to conducting surveys where we sample people and ask them to tell us about themselves, but we can't sample and interview dead people, so we need some other way to learn about deaths. In particular, we're going to look at strategies where people tell us about others who might have died. And the second challenge is that even in places where adult mortality is pretty high in an absolute sense, is pretty high, then in an absolute sense, death is still a pretty rare event. So that means it's challenging from the perspective of sample size, because we would need a pretty big sample to learn about enough deaths to get death rate estimates relatively precisely. So right now, there's two leading approaches to overcoming these challenges and estimating death rates from a survey. And these approaches have been more or approximately unchanged for quite a while, like decades at this point. So one approach is called the sibling survival method. The idea here is to ask survey respondents to list all of their siblings, when each sibling was born, whether or not each sibling has died. And this approach has been used in well over 150 nationally representative DHS surveys at this point. And it's sort of arguably the most common approach to trying to estimate adult death rates from a household survey. Another approach is to ask about deaths in a household. So the idea here is to ask respondents to list the regular members of their household, when each member was born, and whether or not anybody from the household has recently died. And so in light of the challenges that I just mentioned, these two approaches seem promising because we can learn about people we don't directly interview. So for siblings, we can learn about siblings who died, even though we don't obviously talk to the dead sibling directly. Same thing for a household. As long as somebody who died recently would be recalled by a household, we can learn about that death from another household member. And both of these approaches also let us learn about more than one person from each survey response, and that kind of gives us more efficiency, or more bang for our buck, so to speak, from our sample. But there are also some pretty big challenges with these approaches. One challenge is that although we do learn about more than just one person from each interview on average, these networks are relatively small, and so there's some challenges that are associated with that. One is that it doesn't help improve the precision of our estimates as much as we'd like. And then another is that because there's these small networks, there's challenges with people who will be invisible to these reports. In other words, this is sometimes called zero survivor bias. The idea is if someone dies and doesn't have any surviving siblings who would report her death, then there's no way we can learn about that death through sibling reports. Sort of similarly, if somebody in a single person household dies, there's no way we can learn about that death from a kind of death in household report. So I think these are both really good methods. We've gotten a lot out of them, but part of the goal today is to try and improve on them, because the status quo is that lots of countries, like big countries, like the ones I showed you in the map, have something like one really high quality survey-based measurement, maybe every 5 years or so. Often the DHS, for example, is conducted every 5 years. And this should improve. We need a lot more data about adult deaths to be able to estimate adult death rates, but this is extremely difficult. DHS surveys are huge and expensive, and it seems implausible that we'd be able to sort of dramatically increase the number, the frequency of the DHS surveys. So what I'm going to try to think about today is how can we maybe go beyond asking about SIBShips or household members and instead ask about other types of social relationships and use information we get about those other social relationships as the basis for death rate estimates. So that's kind of the big picture that this project is focused on. So if we're going to ask about other types of relationships, it would be really helpful to have some way to think about what the pros and cons, the strengths and weaknesses of a specific other type of relationship is. And I'm going to try to think this through using this idea of the strength of the relationship or the network tie. This is a concept that is borrowed from kind of the sociology of social networks. A strong tie is something like siblings, so it's or maybe close friends. So it's people the respondent will have a relatively strong or intense connection to. And at the other end of the spectrum is what I'll call a weak tie. So this would be something like people the respondent knows, but maybe doesn't have a particularly salient or important connection to. And you can imagine different types of relationships in between. I'd like to think a little bit about what kind of trade-offs might be at play when we ask survey questions about deaths among respondents' networks when the network is composed of different types of ties. So if we ask about a relatively strong tie, like a sibling, we know from the literature on social networks that strong tie networks tend to be relatively small. And that means that we learn about a relatively small number of people from, for example, sibling reports. And that means that the kind of sampling error from our estimate is going to be relatively large because we're not getting a lot of bang for our buck, so to speak, from each interview. And the kind of opposite is true of weak tie networks. If we know from the literature on social networks that weak tie networks tend to be pretty big. And so at least in principle, if we ask respondents to tell us about weak tie network members, we get information about a lot of people from those reports, and that means the sampling error, all else equal, will be relatively small. The prediction for the non-sampling error sort of goes in the opposite direction. We think that respondents will be better informed about others who they're connected to through relatively strong tie networks, like, for example, siblings. And so they'll be able to report relatively accurately about those network members. And that means that we would predict the non-sampling error will be relatively low. On the other hand, for a weaker tie network, such as people the respondent knows, it seems like the respondent may not be able to report as accurately about those network members, and so the non-sampling error will be relatively high. So if that's true, what we care about when we're estimating death rates is the total error, in other words, the combination of the sampling and the non-sampling error. And if these relationships kind of look like the way they're sketched out in this plot, the total error might be minimized at some kind of intermediate strength tie. So for example, if you imagine one extreme being siblings, another extreme being acquaintances, maybe something in between siblings and acquaintances like cousins or neighbors or aunts or uncles will produce the most useful data for estimating death rates. So that's kind of the big picture idea that this study departs from. And so this study had a few kind of big goals. So one is that we'd like to explore lots of different relationships or ties as the basis for collecting information about adult deaths. I'd like to kind of try to start to look at this at the empirical shape of these relationships here to see if there does seem to be some kind of trade-off between the quantity and the quality of information that's produced from each tie. A lot of my work has been focused on developing statistical methods for producing death rate estimates from data that are collected about network members like this. And so that's definitely going to be a part of this study. And then finally, where sample size permits, we're going to actually estimate death rates with these data and compare them to a gold standard. Today, I'm going to show you some kind of preliminary empirical results from these first two goals, and then I'll kind of talk a little bit about where the rest of the project is going. So in this study, we explore 11 different relationships as the basis for learning about deaths. I'm going to kind of do this as quickly as I can. These first three relationships here have been previously used for mortality estimation. Household members and siblings, I already discussed. Parents are also there's a long history of asking about orphanhood as a basis for adult mortality estimates. These, I believe, are all new to the demographic literature. We also ask respondents to report about their aunts and uncles on the maternal and the paternal side, their cousins on the maternal and paternal side, and then also neighbors. In other words, people who live next door to their household. And finally, these three relationships in blue, we're going to ask about three different types of acquaintances. One type of kind of broad acquaintance, and then we're going to explore two gender-specific types of acquaintances, men being connected to other men and women being connected to other women. I'm not going to have time to explain the details of the difference between these approaches, but I'd be happy to talk about them in the questions. The big picture idea here is we're going to look at a lot of different relationships as the potential basis for death rate estimates. To try and do this, we have these pilot data from a sample of about 2,000 adults. This is a random sample of about 2,000 adults who live in the HDSS site in Matlab, Bangladesh. These were face-to-face interviews. Respondents were randomized to one of two different versions of the survey instrument to allow us to explore all of the relationships. And I'm not going to have time to explain that in detail today, but I can answer questions about that if you're curious later. Okay, so I'm going to try to show you some very quick kind of preliminary results and hopefully get you excited about the stuff that's going to come in the coming months. So first, I want to look a little bit at quantity. In other words, does it seem to be the case that there's some that when we ask about weaker types of network ties, we learn about more people and therefore maybe the sampling error is a little bit lower. There's a lot of different ways we can try to quantify quantity from the data that we collected. I'm just going to show you the results from the average number of reported deaths per interview. So kind of like the more deaths a respondent reports on average per interview, in some sense, the more information we're getting about mortality. And this plot here shows on the x-axis that average number of deaths per interview, on the y-axis the different relationships. You can see that there's substantial variation here, especially the weakest tie networks produce a lot more information about deaths than the kind of medium strength and strong tie networks do. So that's kind of interesting. It does seem to be the case that if we weaken the type of network we ask about, we get a lot more information. Okay, another dimension here is quality. In other words, how kind of good the data that are produced from each report is, from each tie is. And there's, again, a few different ways we can quantify this. I'm going to focus on just one. I'm going to show the average fraction of reported network members who are missing age. So that's shown on the x-axis here. Again, on the y-axis, we have all the different relationships. And you can see there's a lot of variation here as well. Somewhat interestingly, these acquaintance definitions, which were really weak, do not have the highest missingness of age, at least for deaths. For reasons I don't have time to get into, we only have the fraction missing age for deaths from the weak tie data. And so you can see there's a lot of variation here. It does, maybe broadly follow this kind of the predicted trend, but these weak tie reports seem to have pretty low missingness relative to the other to the intermediate tie strength ties. Another thing to look at is the difference between the missingness for all reported network members versus those who died. So all the reported network members are in red here, and those who died are in blue. And that's kind of we see this interesting results for cousins that we're going to try to understand a little bit better in some qualitative data collection in the future. Finally, is there some kind of trade-off between quantity and quality? There's a lot of ways we could look at this too. I'm just going to focus again on one way. On the x-axis here, we have the reported average number of network members per interview. On the y-axis, we have this index where higher values imply higher quality. If there's a trade-off, we'd expect a kind of downward sloping relationship here. When we look at all reported network members, which is what this panel shows, we do see some kind of evidence for some kind of trade-off here. But when we look just at deaths, the picture seems to be much more complicated. And I think what's going on here in part is that deaths are so driven by the age composition of the network members that we really have to kind of factor that into the empirical analysis in a way that we haven't done yet. Okay, so just to kind of quickly summarize, I think I've running out of time. There's a lot of variation in quantity across the different ties. And I didn't show you this, but we also find that the ties produce information about lots of different types of people. So sibling ties tend to produce information about people who are like the respondents, while other ties like household neighbor produce a much broader set of information about a broader group of people. There's a lot of variation in quality, and we see some evidence of a quantity-quality trade-off, at least for the entire network, but when we look specifically at deaths, it looks like it's a little bit more complicated. Next steps are to develop some of the statistical methods, actually estimate death rates and compare to the gold standard, which is in some sense the ultimate evaluation of quality, of course. And then I just want to argue more generally that we should try a lot more things when we're estimating adult mortality. I think we've collected the sibling and household type estimates a lot. There's a lot of value in those, but I think we could also do better if we start to explore other approaches to estimating adult death rates. We have these modern methods that can pool estimates together very effectively. We need to produce estimates that they can use to pool together, and I think to see my work as part of that. So we shouldn't let the perfect be the enemy of the good. And when we experiment with new approaches, we should focus on trying to develop a theory that can help us predict what sort of relationship will produce the most accurate death rate estimates. So I kind of described this quantity quality trade-off theory, which I think is a good start, but maybe this study and others will reveal that something else is better, does a better job of predicting. And I just want to say we're also hoping to collect qualitative data quite soon to kind of understand some of the details of why people are reporting about the different relationships in different ways. And I hope that produces insights that will feed back into the kind of quantitative data collection. So, thank you very much.